Hello everyone, this is Freddy. So you may start to wonder why I started to do these useless fundamental tutorials. These are something I wished to do a long time ago, but I didn't have time. These are also questions that I had for a billion years until I figured out myself. And these are also important if you're going to work with splines a lot in the future, meaning today, next tutorial, next tutorial, and the next tutorial probably. Anyway, today we're going to make this seaweed animation. I don't have much time to optimize the tree because either I'm chasing the deadline or the deadline is chasing me. So I think we will just do the optimization together from scratch. This animation is a little bit tricky because firstly, there are two methods. One is to use hair and the other is not to use hair. I didn't have advanced knowledge about the hair system currently, and after testing, I feel it didn't run too well. So I made this animation with the second method, in which we will do something differently compared to the plasma animation that I have done in the past. The difference will be specifically mentioned later. Just to say that up to this moment, I don't know how much time this tutorial will take, and if it turns out to be long, then I will separate it into several parts. So anyway, let's start. So let's firstly briefly talk about the principle of this animation. I'm going to generate a wavy splines and it should be turbulently shaky to its tip. And then I'm going to duplicate these splines with different seed and replicate that on a grid or a circle or whatever stuff. And obviously I want different splines goes towards a different location direction according to their location. Also, I want them to have essentially different length, and I want to animate their growth. One more thing I would like to do is I would like to bevel all the splines to make them having kind of a star shape, outer edge, whatever stuff, as you have seen in the animation. So it seems a lot to do, but the principle isn't that hard because it's splines. So we can bevel the splines. So how to bevel the splines, however? So we can create a circles. So now we have 4 vertices, and we can try to divide that. I'm going to select each second and drag them to the middle. Obviously, you can increase the subdivision and drag them to the middle so that the more like kind of star shape, and so on and so forth. This, however, is not procedural, and I have to select each second of vertices each time, this is chaotic. So I'm going to do a procedural star shape. So let's do that very quick. So I'm going to distribute the matrices. I'm going to change the typing to circle. So if you turn on the 3D viewer, then I have the vectors distributed on a circle. And then I'm going to call each second point and collapse them into the world origin, which means the center. So to do that, I need an index max fourth. So that step is 2 means each second will have a different fourth. And then I'm going to select this node, loop through the vector. And I'm going to, in the parameter, take a fourth. So to put a fourth into the fourth. The reason I make such a loop, because mix vector cannot take multiple inputs. So if I directly put these vectors into A, it does not actually work. So I have to work within the loop. I actually have made a fundamental tutorial talking about the loop. You can search. And then I'm going to, I will keep the B as 0. Next thing I'm going to do is evaluate this fourth. And it takes the index into index, because this index method fourth need to evaluate which start from 0, which one is the second, something like that. And I'm going to put this strength into the vector and hit this plus and take a vector list output. So now I'm outputting a vector list. So really there was a person who asked me where I can get this kind of nodes, but the point is you need to hit this plus. You cannot really search for a vector list output. It does not work. So then if we take a look with what we generated, you can see each second point collapsed to the center perfectly. But this is overdoing stuff. So let's just, I think the easiest way is to make a clamp. And I'm going to take down this one so that you can change the degree, and that's it. So then we generate a spline from point. So up to this moment, we no longer can see the splines. If you really would like to see the splines, you can just make a curve object output. Change the bevel depth to 0.1 and make a target, so that at least you observe that. So now this is very jaggy. We turn on the cyclics. We can smooth these splines out. Smooth bezier spline. Now we have a kind of very beautiful star shape, and you can definitely change the bevel amount. This is completely procedural. You can change the amount as well. So you can make a square or more star-like shape. This is much cooler than you do this by hands, definitely. I think this is essentially it for the star shape. So next thing, we're going to really work with the splines that are shooting up. So you can either start with a complete new tree, or you can work the original tree. It does not really matter. So I'm going to work with the same tree. So I put everything into frames, and then just call that beveled spline, and move that to the other places. And I'm going to hide all this target. Okay. So before we make a spline that is shooting to skies, I'm going to distribute the matrices to make a grid so that we can place the splines. And then I need a object instancer node. We can select these bezier circles. Remember to copy full object and deep copy. The whole point of using these things is I just need an object, a spline, a curve object, but I don't care what it is because we're going to update its mesh later. Then I'm going to select this node, hit W, go to right, loop through object. Okay. And I'm going to hit plus of the iterator and take a matrix list input. So now we're basically generating grid, and we're going to make our splines that are shooting up to skies within this loop. The whole point of doing these things is we now currently within this loop we are in one of the location of the grid, like this one. Think about this one, and we are going to make a single splines. Oh damn! We're going to make a single splines within this location, and by changing the seed, which means the index, then we are generating different splines, and so on and so forth. Okay. So how to generate a splines that is shooting up to sky, that I have explained in the other tutorials, including the fundamental tutorial, is basically just clean up the X division and make the Z division like 5. So take the 3D viewer, take the vector, as you can see, now we have a spline that is shooting up to sky. Cool. I want a different spline have different lengths. I will specifically manage this later. So far you don't necessarily to worry about that. But I will put this Z division back to the parameter, and I will name that X kind of a resolution, a spline resolution. Because more points you generate for a splines, essentially it just has more resolution. And remember just not to take this Z, otherwise everything will be offsetted, but I want it to start from world origin. Okay. So next thing is how to how to weave all these points. In my plasma animation, I use the vector wiggle. And if you put a vector math, then it will just add the wiggle amounts to all these points. So let's make it a list. Put the vector into count. So now let's turn down the amplitude, turn off the Z. So now we're wiggling a point. And by using this evaluation, we are wiggling these points. But the problem of this specific things is I feel like these points are just randomly wiggling by themselves. Okay. If you're generating a lot of points, let's see these many points, then you don't see a kind of coordination of all these wiggling. They're just wiggling by themselves. And this is not essentially what I want. So here we're going to do a kind of different method. So let's take the spline back. I'm going to use a different method. It's called a vector noise method. So currently vector noise is a 2D noise, which means it will generate a line. So you can see it outputs a float value, but we need a vector. So let's just make a combine vector and plug that to X currently. I'm going to change the type into Perlin because I think Perlin is softer. And then I'm going to put this vector into vector so that it generates kind of 2D lines. And by animating these offsets, then we're wiggling these splines coordinatedly. You can see essentially if we are increasing the amount, you can see it's a kind of coordinated line, which is very smooth. And by increasing the frequency, definitely you can make it more jaggy and less jaggy. But it's just a kind of very beautiful lines that you can work with, and you can increase the amplitude as well. So you can see the wavy like this, definitely very different from what we see previously. But also now you see a problem. Is as I'm waving these objects, then it does not stay its world origin. It's just so completely random. And I want to change this. So how am I supposed to do? So I'm going to generate a loop. Yes, I think I'm going to generate a loop input. So basically it goes to right and loop through this value. Let's delete this loop input. So now we are inputting a float number. So when it starts, I want it turns to be 0. So let's make a float range and turn that to stop. And the amount will be the amount of iteration. Okay. And I'm going to float math multiply this number. So this number turns to be a factor. Get list length. Get list element. So this number turns to be a factor. For the first number, for the first float, it will multiply a number with 0, which means it will not move. For the second number, it will be a number which is a little bit higher than 0, so it will start to move. And for the last number, it will multiply with a number which is 1, so it will completely move. So you are generating such kind of gradients for it to move. This is the idea at this moment. So if I take the start and stop back to parameter, we can control that through this at this location. And in this, I'm going to generate a output float list, goes to result. So, and I'm going to take this loop to other places, just hide that forever. And then I'm going to put this float list back to place. So now you can see it. Now I can start to freely wave these guys, and it starts will stays at a position. I think the amplitude is too high, but this is completely animatable, so you can just do whatever you want. Very, very cool. Like a kind of, how should I say, I forgot the insect or whatever animals call these things, whatever. But now we're only working with X. I also want to work with Y, but not Z. So let's just do another vector noise. Yes, let's just do another putting noise. Put the vector into, and I'm going to change the seed and duplicate this loop. Put the float mass, put into y. Just remember, if you would like to procedurally change all these parameters in other places, like at the beginning of this loop, put everything into the parameter, like the amplitude, frequency, no, I think I'll probably not change the start and the stop because we have amplitude already to change. Okay, so this is basically now this is done. So now we have these points. Let's just spline from points. So now we're generating a splines. Let's smooth better splines. And I'm going to put the objects that we have the most at the most beginning. To the object. I think up to this moment this is fine. If you take a look with the splines we're generating, so let's turn off the 3D viewer. You can see we're generating a single splines shooting up to skies, but we're actually having 9 splines in total because we are running the same loop over and over again. So here's one thing firstly I have to say is we're going to change the seed for each splines. To do that, I'm going to use the index because this loop will be run for 9 times because we have 9 grid to run or 9 objects to create. And for each time the index will change from 1 to 8. So this is the principle. And so I'm going to use this number to change the seed. So let's add a float mass. Let's just multiply like 25. So one index goes to seed, and the others goes to the other seed. So that generated 2 different seeds for them. I probably also multiplied more advancedly so that I put a seed numbers into parameter and put the seeds to the top. And this is basically it. You can manage the tree better essentially, but these are the ideas so far. So by changing, so let's go to the seed. So if we just change the number, then all the seed has been changed. Very cool. And I can definitely offset the numbers. They're flowing very coolly. Very cool, very cool. I think this is just I think this tutorial can already be done. I think this is already something completely interesting to see. Our end goal is to assign these 9 different splines to 9 different locations, and that's why we are putting 9 different matrices into this matrix list. And now this is the moment we are going to use this matrix list. So firstly, let's organize this tree better so that we can see things more clearly. So let's just collapse all these meaningless values. I'm going to shift right mouse to add a reroute. Combine vector, collapse that. So now we have this vector mass, and we are putting this vector mass into the spline points. And for this vector, I'm going to take a transform vector. And here now we need to input a matrix, and that's why we are having this matrix earlier. So add a reroute to make it clear. So now this looks much nicer. Let's just shrink this node tree so that we can see where we're going. And I'm also going to plug these bevel depths back to the node tree so that I can change the thickness of all these splines. And I'm going to change so now everything has been spreaded too much. So I'm just going to take a integer input and float input to synchronize the change of x and y. So 3 for x and certain numbers for x and y's. And definitely you can add more, and definitely you can offset the metrics to add some variation in the location and so on, but I'm not going to do that at this moment. So now here's one thing. So if I'm changing the bevel depth, then you can see the thickness has been changed uniformly. But this is not what I'm looking for. What I want is it will start kind of being thick, and then it will shrink to at its tip. So how are we going to do this? Then we're going to, so by changing the bevel depth, it will change everything uniformly, but we can change the radius by inputting a list so that it will shrink at its tip. So we need a float range, and the number will be the number of resolution within. So let's take that in. Yes. And then I'm going to put this list into radius. So now everything becomes collapsed. Let's just change this number to very low. Okay. So this is also the step. So let's change that to stop. So it will stop at 0, but it will start to be very thick. So something like that. So now this tends to be kind of stuff. And this list is linearly starts from 0.18 and linearly stop at 0. I want to have a different kind of curvature. So let's just generate a map range. And obviously you see that so let's make a, how should I do this? Let's make a float input. The whole point is I want to synchronize the max number with the start number. So 0.18 and output max should be the same. So now I'm using the map range doing completely the same thing. If I input 0, then output 0. If I input 0.18, then output 0.18. So why do I need this node? Because I need this interpolate. If I'm interpolate different values, so like use a, let's think, curve interpolation. So curve interpolation, basically its x-axis is the inputs, y-axis is the outputs. So for the lower input, it will have higher outputs according to this interpolation. So that's why if I'm lifting this point, then it will stay thicker as the time goes. And definitely you can play around with this interpolation, but just be aware. So firstly, I'm putting this always off because I don't want to burn my computer. Secondly, this curve interpolation does not update the tree very well. So there are several ways to do this. One way is just keep the frame changes and update that. So now it's keeping updating itself because the frame is changing and it's a trigger of the execution of the tree. Or you can simply just turn always on, but remember to turn this always off, otherwise it will really burn your computer. It's not something that you wish to see. and you can just change the interpolates as you wish, and so on and so forth. So now I think this is it. You just play with the interpolation by yourself. It will be fine. I'm going to plug this float input back. So let's just put a float input, float. Yes, radius, base, or you can call that radius start. And let's change the number 0.2, something like that. So now we have this part being done. Okay, cool. After this part, I think we've already spent too much time in making this animation. So I probably put everything in the next tutorial to make some more improvement and modification to achieve the proper end result. So I hope you enjoyed this tutorial, and I'll probably see you at the next part. Bye bye.